So started on some power supply stuff for the power factor correction stage, ordered parts for a prototype. Pretty beefy parts, pretty beefy. The main thing we're missing, so it's this really popular like rectangular part that's a full bridge rectifier with studs on it. Does about 15 amps. It's far more than anything I would need. And so you have that. It goes to a inductor, FET, switching it to neutral. Then you've got a diode, so that when you turn the FET off, the collapsing magnetic field shoots it through the diode. And then you have a capacitor, and you have a capacitor on the intake side too. And then you have one on the output side, which needs to withstand about 400 volts. God. And yeah, the most expensive part. Okay, so the inductor may be the most expensive part. I haven't made it yet. I know I need around 220 microhenries. And then I might be remembering this wrong. I think I ended up needing about like 220 microfarads also. The inductors I bought cost about $15 each. They're pretty big, but they are also very high current. If I needed, so they're sized for about, I think, a 6 kilowatt supply. And so the trade-off with those inductors is you can have fairly small inductors that have iron cores in them with high inductance. The issue starts to be if you start putting high current through them, they saturate. So this has a bigger core, bigger wires. I did order some small cores. I'm not sure I want to go buy Litz wire. I was trying to look at existing designs so I could see what's cheap, because yeah, sure, I can do the math and get very precise values, but when you do that, you end up paying an arm and a leg for them. And even when I found some existing designs, the freaking capacitors on those things, they're like, I'm still convinced I'm buying the wrong capacitors, or maybe these designs are just like super smooth, creamy, very low voltage ripple ones. So yeah, it was like a 150 plus microfarad capacitor, and those were like $40 each. And so, having taken apart some of those power supplies, if you really are paying tens of dollars for a single component like that, I can't really see how they make the economics for that work. So I doubt that. Anything else? I mean, that's going pretty good. I also found this really cool part. It's like that big, and it's got you can see the exposed die, and it's a PFC stage in a chip, but you need to supply the inductor and the capacitor. It has the diodes and the IGBTs. It is not exactly a critical conduction mode. It is bridgeless. Well, so there's bridgeless and then there's conduction mode, and so it is bridgeless, and it has IGBTs in it. I thought the choice of IGBTs was interesting. I am assuming because it's more rugged, I couldn't find anything in the data sheet, because it was made for white goods, like, what do you call them, air conditioner. So that'll be fun to follow up on. That was like $200 in parts. The MOSFETs were pretty good. I was able to get some really nice, like 0.08 milliohm FETs. The one niggle there is their gate source is very high. It's about 30 volts, and so I had to get drivers for that. And that is the one thing I was not able to find very easily, or I'm just going to have to use, like, the one problem I've been having finding information about these designs is the bias voltage. And so that's kind of like an old tube amp term, where you need to bias certain components before your entire powertrain has come up. And there's like there's embedded little modules that you can get. The trick though is, how do you get the line voltage to come off? I found a couple. I need to do like a complete teardown because most PSUs are so packed I can't really figure out what it is. So that's it. I'm going to have to use a couple bench supplies to do that at first. But it's a really nice MOSFET. I was honestly surprised. Extremely low gate capacitance and extremely low on resistance. Switches crisply. The other one was the diode. The diode I found was pretty good. It wasn't silicon carbide. I found a silicon carbide bridge rectifier, full bridge, that was like $1,000. Not quite there yet. The silicon carbide FETs is what you try to use for a diode, but you need to. No, I guess you don't. I need to limit the scope though and just get this working. So we're making progress on doing that. So